Hello guys, in this video we are going to design stirrups for our concrete beam. So this is our 12 feet long concrete beam with a 3.6 kip per foot distributed load on it. So our shear diagram is this one. So 21.6 kips our maximum shear on this beam. So BW is given 10 inch or D is given 16 inch. 16 inches. So our FYT, the steel yield strength for our stirrups is given 60 psi, and the concrete compressive strength is given 5 psi or 5,000 psi. So the first step is that we have to find our demand shear force. For that distributed load, our demand shear force is QL over 2, that we can get 21.6 kips. So the next step that we need to find the concrete shear capacity. Our concrete shear capacity is given by this equation. Vc is equal to 2 gamma multiplied by square root of fc prime multiplied by bw multiplied by d. Gamma is 1.0 for normal with concrete, so we are going to use 1 throughout our calculation. So just make sure that fc prime has to be in p side, not in k side. So we divide by tau 1000, so we get our result in kips. So our VC is 22.627 kips. BW is given 10 inch and D is given 16 inch. So the next step is you need to check if the stirrups are required or not. So we have this relation here. If VC over 2 is greater than VU over phi, yes, stirrup not required. If no, stirrup required. So our VC over 2 is 11.31 kips and VU over phi is 28.8 kips. Phi is 0.75 for shear. So now, since our VC over 2 is smaller than VU over phi, then stirrups are required. The next step, check if beam section is okay or not. If VU over phi is greater than 10 square root of fc prime BW multiplied by D, if it is greater than, yes, increase section. If no, then no need to increase. So VU over phi is 28.8 kips, and this is 113 kips. So VU over phi is smaller than 113 kips, then section is okay. We don't need to increase the dimension of our cross section. So the other step is record stirrups capacity. Now we have to find our stirrups capacity. So we have this equation here, V multiplied by Vc plus Vs. Vc is for concrete shear capacity, V is the stirrups or steel shear capacity. It has to be greater or equal to Vu, demand shear capacity. So Vs is equal to V over phi minus Vc. So we can, after plug and chug of those Vu and Vc, we get 6.173 kips. We go to the next page, and the next step is we have to find the maximum stirrups spacing, or we call it S max. So if Vs is greater than 4, fc square root of fc prime multiplied by bw multiplied by d, if it's greater than this, then yes, maximum spacing has to be minimum of d over 2 or 12 inch. If no, then maximum spacing has to be minimum of d over 2 or 24 inches. So our Vs is given 6.173 kips, and the other value is 45.25 kips, which is greater than our Vs. Then we have to use this value to find our S-max. So our S-max is minimum of 16/2, 8" or 24". Now 8" controls, which is the minimum of these two. Minimum stirrups area. So if we have a beam and we have a stirrup, this is the stirrup area, and this is the EV, we call it. This is for area of two legs. So we can get our minimum stirrup area from these values. So we have FYT, we have VW, we have FC prime, and we have S, which is already selected from here. SMAX, 8". After plug and chug all these values, we can get the minimum AV is 0.707 square inch. This one controls. So based on this area, we can select number 3 rebar. The area of number 3 rebar is 0.11 square inch. And EV that we needed, we have two legs and we multiply the 2 by 0.11 square inch, we get 0.22, which is greater than 0.0707 square inch. And we are okay. So now we find the shear capacity of our stirrups or steel based on the EV that we get, two number 3s. So this is the equation for that. Vs is equal to EV multiplied by FYT multiplied by D over S. So you plug and check all those values and we get 26.4 kips. So the final step, so we check the beam shear capacity is okay or not under the demand shear. So phi Vn has to be greater or equal to Vu. So phi Vn is equal to phi multiplied by Vc plus Vs. Vc is for concrete and Vs for steel is 0.75 multiplied by our Vc is 22.627 kips plus Vs is 26.4 kips is equal to 36.77 kips. So our phi Vn is greater than Vu, which is 21.6 kips. We are okay. So now we're okay to select number 3 rebar at 8" center to center. Just one thing, keep in mind, it's off the subject, but I just want to mention it. So this is a beam column joint or beam support. So normally the shear occurs like this. It's for beam and slabs, normally 45 degrees. So this, based on the experiences, so this area is the D away from this face of the column or from the support. These two are our critical section. So normally we find VU or demand shear in this area, then we design our stirrups based on that. So this is the D. So D away from the face of column, these two are our critical section. So if you have the shear diagram over here, so this is D away from the face of column. So this is our VU max, and we use this view, and we can use the triangle similarities to find this view and design our stirrups. Thank you guys. I know it was a little fast, but you can pause it and stop it, slow it, and watch it and learn it. I hope it's useful and solve your homeworks. Thank you very much. Bye.